Hey guys, I just wanted to jump on and welcome you to this class. And I also want to give you a quick overview of how this class is going to be run and what you can expect to learn. Okay, so let's review what is on the docket for this year. Okay, so the course itself is going to be broken down into main units. We are going to start the year. Hold on, what's going on? Okay, we are going to start off the year just reviewing some math concepts. Okay, we are going to review some things that you've probably learned in prior classes, including unit conversion, because we definitely are going to have to convert between units in this class. We are also going to review triangles. Probably coming into this class, you have no idea how many times you are going to deal with triangles in physics, but it's true. That's why a prereq for this class was geometry or its equivalent, because there are just some things that I'm going to need you to know how to do, including using the Pythagorean theorem, understanding the angles of a triangle, that sort of thing. But we are going to review those. So if you're feeling a little bit hazy about the details of triangles, we're going to review them. We are also going to use trigonometric functions. Those include sine, cosine, and tangent. That's related to triangles as well. Now, if you're thinking to yourself, I have never learned about sine, cosine, and tangent, this class is not for me, that's not true. I did not make trig a prereq for taking this class because I don't think that it is a prereq for taking this class. We are going to spend an entire week reviewing the trigonometric functions. And I am going to teach these topics as if none of you have ever heard of them before. So if you've never heard of them before, you're in luck. I'm going to teach you how to use sine, cosine, and tangent. Okay, so don't freak out about that, but make sure that your scientific calculator does have those sine, cosine, and tangent functions. Okay, so once we are done reviewing math, we are going to move into kinematics. And kinematics is basically the study of motion. So as you may expect, we're going to be talking a lot about motion in this physics class. This is where we're going to get into the nuts and bolts of it. And we're going to spend 9 weeks at least on kinematics. As I said, if we have to make adjustments, we can make adjustments. But we're going to break this down into two subtopics. We're going to talk about motion in one direction. So if we're just going north and south, or we're just going east and west, that sort of thing. We're going to talk about speed and velocity. How are they different? Acceleration, free fall, distance, displacement. Then, once we're really good at understanding those topics, we're going to move into talking about motion in two directions. So instead of going north and south, east and west, what if we're going southeast? What if we're going northwest? And we're going to talk about vectors, relativity, and projectile motions. So that's going to be really, really fun. So this is basically how we're spending the majority of this first semester. Then we're going to move into talking about forces and the laws of motion. We're going to spend about 4 weeks here. This is where we're going to talk about Newton's three laws. We're going to talk about the difference between mass and weight. We're going to talk about something called the normal force, which is really, really cool. We're going to explore friction and tension, inclined planes. Inclined planes involve a lot of triangles. We're going to talk about forces acting on objects in 1 versus 2 dimensions, and we're going to learn how to draw and analyze what's called free body diagrams. So that's going to be a lot of fun. Then I believe that takes us through the first semester. Then when we come back from our winter break, we're going to move into learning about momentum and collisions. So, lots of different applications, related to this. Because I assume a lot of you are new or soon to be new drivers, a lot of my examples this year are going to involve driving scenarios. You're going to learn why we use seatbelts, why airbags are important. We're going to talk a lot about this in that section. Then we're going to move into work, energy, and power. If you've taken chemistry, you've probably learned about potential energy a lot, even kinetic energy. When we're talking about thermodynamics, we're going to talk about this and how it comes into play in physics. Going to talk about kinetic energy, potential energy, how energy is conserved within a system. We're going to talk about what work is, what power is, and once again, we're going to relate this to driving when we consider stopping distance. In other words, if you're traveling down the road at a certain velocity and something jumps out in front of you, how long is it going to take you to stop your car, even if you put the brakes on full force? We are going to spend a week talking about uniform circular motion. This is when we're going to talk about centripetal force. Some really cool applications involved here. We're also going to talk about the universal law of gravitation. Now, we will have already been talking about gravity from our time in kinematics. We're going to start talking about gravity, but this is going to be a little bit different. The universal law of gravitation is gravity as it applies around the entire universe. It's different than gravity that we are associated with on Earth. I mean, it's not different, but gravity on Earth is like one subtype of all gravity. So this is when we're going to be talking about all gravity in the universe and how it relates. Then we're going to spend a week talking about torque and simple machines. This was a topic that my students in the other academy I taught for really wanted me to include, so I'm including it. We're going to talk about angular momentum. We're going to talk about center of gravity, and we're also going to consider the simple machines. This was the very first year I was teaching this class live online. One of my students really wanted to study fluids. And my son, who is an electrical engineer, he had already told me that this was one of his favorite topics. So I prepared this unit and it remains one of my favorite units. So I'm so glad for those people that encouraged me to include this unit. So in this week that we talk about fluids, we're going to talk about fluid pressure, buoyancy, Archimedes principle, Bernoulli's principle, which relates to airplane flight. It's a really, really fun unit. Then we're going to move into our study of waves. A lot of physics is related to waves. So we're going to spend 1 week just talking about waves in general wave properties, amplitude, frequency, that sort of thing. We're going to talk about the difference between longitudinal and transverse waves. We're going to learn about what's called boundary behavior and constructive and destructive interference. Then we're going to talk about sound. Sound is a wave. We're going to talk about sound. We're going to learn what music is, how echoes work. We're going to learn about the Doppler effect that is really fun. We're going to relate the wave properties that we learned in the previous weeks to how they relate to sound. In this unit, you're going to have an opportunity to choose some topic related to sound and take part in a discussion project with your peers in which you educate your peers about whatever topic that you have chosen. Then we're going to talk about the electromagnetic spectrum, light and color. So we're going to talk about electromagnetic waves, which I know that you've already covered in some form or fashion, probably in a different course. We're going to compare human vision and animal vision. We're going to talk about color addition, luminous versus non-luminous objects. Once again, you're going to have the opportunity to choose a topic, complete a discussion board where you educate your peers about your particular topic. Then we're going to study optics, and it's not going to be long enough. We're going to spend 1 week. We're going to be talking about convex and concave mirrors and lenses. We're going to talk about the laws of reflection and refraction. We're going to learn about corrective lenses and how they work. Then we're going to spend our final 3 weeks learning about electricity and magnetism. We're going to break it up. We're going to spend 1 week talking about static electricity and another week talking about current electricity. We're going to learn how circuits work, resistance works. Then we're going to talk about magnets, magnetic fields, electromagnetic induction, and how AC/DC power works. So these are the topics, okay? They may seem intimidating to you right now. Um, just imagine by the end of the year, you're going to know so much about these topics that you don't already know. And I think that that's really fun. I would love to know what topics you're most excited to learn about